Yeah, so we built the sphere. It was basically the same as the circle class, but the sphere also included x, y, z coordinates, which was, handy. Because we wrote a couple of extra methods. We wrote a method to calculate the distance between circles, or spheres. Their centers, their edges, we asked if they overlapped. That was the idea. And then at the end, we wrote a bunch of tests. But again, and I guess the big thing here was we also learned about these two other methods, the repr. That was the special one that basically tells Python, okay, when someone prints out something of this type, something of class sphere, this is what I want you to look like. So if I were to print out some sphere, it would look like, well, this, but rendered correctly. Instead of like underscore underscore main underscore underscore dot sphere at ox something 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 something, which isn't very helpful. Instead, this says sphere and it just tells you its attributes. That's a pretty standard basic what your repr looks like for an arbitrary class. And we also talked about the equal one, EQ. This is where you tell Python what it means for two instances of this class to be equal. It could get a little bit more nuanced than that. They don't even necessarily need to be, well, let's not get into that. But this checks if two things are, in fact, equal. And for our purposes here, this was an example of what it would look like for the circle class, if we were to go back and edit for the circle class. In order for two things to be equal, they first must be the same class. If I'm trying to compare a circle and a string, they're not the same. But if they are the same class, then we'll say they're equivalent if their radius values are the same. That's what we'll say. Had something similar here with the sphere. If they're both spheres, check if their x, y, z's, and radius, if all their attributes are equal. If they are, they're equivalent. If they're not, they're not. And we're defining it. If you're thinking, well, how would I know how to say what it means for them to be equal? That's up to you. You're the one inventing this class right now. You're making it up. I said it's if all the attributes are the same, great. If you were to say, no, I don't really care if the spheres are in the same point in 3D space, all I really care about is if their radius are the same. Sure, you could do that. You can make your sphere equals, not care about the x, y, z coordinates. It doesn't really matter. As long as you can make sense of why it's done that way, it's fine. So here I did compare the x, y, z's, but maybe you decided you really don't want to. Cool, fine. There's nothing wrong with that. But be very mindful of what's going on, like in this example on line 9. If instance other is a sphere, that's checking, okay, is the other thing a sphere? If it's not a sphere, don't bother comparing. Because imagine other wasn't a sphere. Imagine other was a string or something. Imagine we didn't do that check. And then suddenly I say, hey, other.x. But other's a string. And I tell the string, hey, give me your x value, your x coordinate. What the hell is a string going to do? The string is going to go, that's not a thing. I don't have an x coordinate. So that's why it was important to do this check. Otherwise, the program will crash. And crashing is not the same thing as they're not the same, as returning false for equals. Now, just as a note, do I have an example here? I do not. Imagine for a moment that I had two sphere classes implemented. I don't at the moment. But let's say I do. If I had A and B equals imagine this code was working. I don't have the sphere classes written in here right now, so it's not going to work. But imagine it was. remember, I never call these magic methods directly. If you're ever doing something like this, you're doing it wrong. Don't do this. You don't call these methods directly. The way you call it is by saying, then Python goes and says, oh, okay, so when they call equals equals on something of this object, I go look up the underscore underscore EQ underscore underscore method for that class. That's how this one is called. In a similar way that we never call underscore underscore init underscore underscore directly, or the underscore underscore repr underscore underscore. You don't call those directly. In this way, if I go back here, when I call this A equals equals B, Python will go and run this code. In the context of running it like this on line 4 right there, which of those two reference variables to spheres is self going to be? A. And then other will be, of course, B. If I were to write on line 5, what will self be? And other will be A. And then, for fun, well, A, self and other will both be B, which is rather silly, but that's the way it will be. Any questions? By the way, this is all review, so if you're thinking and wondering, why am I going so fast? Because we already did this. Any questions? What I just said wasn't to say you shouldn't have questions. No, I'm doing the review because I'm worried that you might have questions before I carry on. No, we're all okay? We're all good? All right. So we completed the sphere class, and it's going to work for our need, but there are a few things we could do to improve the design. To be clear, there is nothing wrong with the sphere class. What I'm about to show you is not to say this is the right way to do it. No, I'm saying perhaps this is an improved way to do to improve upon the sphere class. Because remember, code is an evolving living thing. Once you wrote the code to do something, it's not done. You should go back and make it better. In terms of perhaps even like how good the code is in terms of efficiency, whatever that means. And just how well it's coded, how readable it is, if there's something about the design that can be improved. These are all things you should be aware of. Obviously, at this stage, you're not supposed to be experts in design of like engineering systems like this. No, obviously not. You're learning. The reason I'm showing you this as a perhaps improved design is to just show you a different way to do it. And maybe you think, yeah, okay, I can see how that's helpful. So when you really think about the sphere had its x, y, z coordinate. But really that in itself is like one piece of data. That x, y, z defines a point. So perhaps what we could do is let's make a new class called a point 3D that's going to manage all of the point-related stuff. And into a specific one point 3D object will keep track of its x, y, z coordinate. And they can actually, those points can then do the like, well, what's the distance between these points? If I'm writing code to represent spheres in a three-dimensional space, maybe I'm also going to want to represent cubes and other shapes and whatnot, all of which are going to have this common property, like these points in space that we need to define where these objects are in this space. Let's offload that work to a point 3D object. Then my cube can also make use of this point 3D object. Instead of like recreating all the functionality, all that like point calculation stuff that I did inside the sphere, that way I don't need to redo it inside the cube as well, if I extract it out into its own point. Does that make sense? The sphere currently manages all of the like point-related stuff. But why can't, maybe I'm going to want a cube object, and the cube's going to need to know points. And if I'm calculating the distance between things, am I going to recreate all of that functionality or those methods in the cube class? Why don't I take all those like point-related data and functionality out of the sphere class into its own class, the point 3D, and then the sphere can use that one, and the cube can use that one, and any other variety of shapes that I could want. So the point 3D is going to know its point 3-dimensional space. We can calculate the distance between points, and we can check equality on points. Maybe we'll want a repr as well. Maybe in the future we're even going to want to add additional functionality to this class, but for our purposes right now, I think this will do the trick. There's nothing wrong, though, with the original sphere implementation. So what do I have here? Okay, it will make our sphere class simpler and easy to understand if we extract all that point functionality out of it, that's for sure. It allows us to write methods at a higher level of abstraction, which, since we can deal directly with point 3D objects, like, remember when we calculated the distance between points in the sphere? Remember when we wanted to calculate the distance between the edges of the spheres? First, we need to calculate the distance between the points, then we subtract the radius values from both of the spheres. You know, there's nothing wrong with it, but in terms of like, perhaps a better design is to have these point objects deal with the point-related stuff. Tell me the distance between the center points of the spheres, and then those points give me that information, and then I subtract the radius values. I think this will be clear as we go. I'm trying to motivate it, but I think maybe as we see how it goes, it'll be a little clearer. Yeah. Oh, another thing that's really nice too. Remember how we saw moments ago the ending of the sphere class, and even at the circle class, those like assert tests we were doing, they were getting pretty cumbersome. Well, if we take all that point stuff out, it actually makes the sphere functionality and the point functionality kind of like separate. They're more independent, where when they were a part of the same object, they're inextricably connected, right? Obviously, a sphere will have a point, but if a point is in and of itself independent, we can test all the point functionality and then the sphere functionality instead of testing all the point and sphere functionalities for the sphere class. It's a little nicer. So a point class. It's going to replace all the coordinate details and whatnot from the sphere class. The class is going to have 3 attributes, x, y, z. The class will also have a few methods, including some to replace the functionality in the sphere class. A method for measuring the distance between points, a method for checking if they're equal, and a nice human-readable repr thing. So here, let's start. I'll get rid of the doc string for making it a little more brief. Any questions about the constructor here? It has the 3 parameters, and then it assigns its corresponding attributes. Again, be aware that the name of these parameters does not matter. The fact that they are both x's, though, is because, well, it just makes sense because the first argument I want to give the constructor is the x coordinate. So I'm going to label it accordingly. And remember, if I don't have self.x and x are entirely independent like variables. They have the same value as a consequence of line 5, but they are not the same. When this constructor finishes running, that x parameter disappears, but self.x doesn't. It's saved and remembered by the instance. So that's all we need to get started. So there. There's the distance from point method. I can ask 2 points how far apart they are from one another. Again, notice here that the other is a point 3D in quotes. That's just because it's being written in this class, so it doesn't really exist yet. There's more to it than that, but that's the easy way to think of it. And then let's do equality. Get rid of the docstring. First, check if they are if other is in fact a point 3D. If it is, go on and do the check, otherwise return false. 2 points are considered the same if they are in the exact same position in 3-dimensional space. If the x, y, and z are the same. And then a nice human readable repr. Oh, there's a typo here. This owes a magic method. There. That's it. That's the whole point class. Let me zoom out a bit so you can kind of get a sense of how. That's really it. Take a moment, look at it. We've got our class point 3D, we have our constructor, initializer, whatever. Assigning the 3 attributes. We've got a method that's just going to tell me the distance, Euclidean distance between the 2 points, whatever self is, whatever the current. Because remember, I call this method on a point. So I would say, hey, point A, how far away are point A dot distance from point B, and it would tell me. So it tells me the distance between those 2 points. I've got the equality and the repr. Let's run this. Make sure it passes some sanity checks. So now print A, that's what we get based on the repr. Here, let me make sure it's clear to you. When I go like this, okay, I got rid of the repr. And when I run this and I say print A, it uses that default repr. I didn't write it. Python gave it to me for free. But then when I go back and I add it, I override the one I got for free with mine. And so when I run it, it actually calls this repr the one I actually wrote, which is, in my opinion, a little bit more nice to work with, because I can look at this and be like, oh, it's the point that's at 0, 1, 2, as opposed to memorizing memory addresses, and I don't know, that's nonsense. Right? Cool. Are they equal? No. They're at different points in space. And if I say, hey, A, what is your distance from point B? It's going to tell me it's that far away. I'll believe it, I guess. And here's a bunch of assert tests. Oof. And it looks like they all passed. Great. But you know, like these assert tests are getting kind of, they're kind of, there's a lot going on in these blocks of code. Also notice that it's actually not, when I call print A, we see that nice string representation, that repr one. But it's not actually printing it out that called it. It's actually when I convert it to a string, like this. It's just that when I print something, it automatically wants to convert it to a string before it prints it out. So just a little piece of trivia there for you. See? If I say, give me the string of the point, it should be equal to that. Any questions? You're all being really quiet, and it's making me uncomfortable. You're freaking me out. Does that mean everyone's good? Everyone's happy? See, I worry about reading week. I think reading week, I think it's bad for a lot of you, to be honest. Who here's ever run long distance? Long distance before. And let's say you're getting close to the end, right? You've got 2 kilometers left, right? You've been running for a long time already. You got 2 kilometers left. One of the worst things you could ever do, your job is to finish this race. One of the worst things you could ever do is stop. Way harder to get started again. And that's what I fear happens to a lot of people after reading week. If you needed the break and you feel better, good, but make sure you can restart. Just saying, it's not over yet. I'll ask again though, any questions? So we've just made the point 3D object, but now we would actually have to go back and alter our sphere. Our sphere, we'd want to have it make use of this point 3D thing. So let's recreate our sphere class. So here, we're making our sphere again, but this time you'll notice it doesn't take an x, y, z. It takes a point 3D object. And instead of an x, y, z attribute, we have a center point attribute. Still has a radius though. Now, here. Oops. Okay, there. Right, so I'm printing out some point, but I created the point and then I gave it to my sphere. So if I say my sphere dot center point, it's actually my sphere dot center point is an alias for some point. It should be clear. And when I print out my sphere.center point, you'll notice it prints out as if it's a point 3D object, which it is. So that's good. That's really good. You might be wondering, you know, could I have done this? Instead of creating the point and then giving it to the sphere object, why not give the sphere object the x, y, z coordinate and then have the sphere object just create the point in the constructor? Say that again? That's true, which is not necessarily a bad thing. In fact, that might be a good thing. I don't know. But let me show you what I mean. Oh, I got to rerun it. There. So here, when I created the sphere, I did it in such a way where it needed 4 parameters, the first 3 being the x, y, z coordinate. But the first thing the constructor for the sphere did is it went and turned those x, y, z coordinates into an actual point 3D object. That's what happened on line 9 of the above cell. And we can confirm that it is in fact a point 3D object that's there because after, in the second cell, when I printed out my sphere.center point, it came back as a point 3D object. And this is entirely fine. There's nothing wrong with this, but the way this is done now is we've kind of coupled the code, the point 3D code and the sphere code a little bit more than maybe I needed to. And it's kind of hard to see why this is important at this stage, but the problem is the sphere is creating another, so first of all, the sphere object's constructor actually goes and creates another type of object, a point 3D object, which is fine, there's nothing wrong with that. But this code now, like very much, like it has an internal dependency on a point 3D object. By doing it this way, we've injected the dependency into the object. And this helps keep our code slightly less coupled, which can be a good thing. And when your code is done this way, it's also a lot easier to test, I'd say, too. So just as a note, you're probably not going to gain an appreciation for this until you get more experience programming and you see how this decision can impact your code. And doing it one way or the other isn't going to screw you over. You're going to be fine one way or the other. But you know, this way is perhaps a little nicer, I'd say. All right, the methods now. So the sphere methods, the diameter, surface area, and volume. They're all the same. They don't depend on the point 3D. They don't care about the x, y, z coordinates at all. It's all based on the radius, right? But now when it comes to the distance between points, instead of doing all that Euclidean distance calculation, I just say, okay, self-center point, what's your distance from point other dot center point? If that felt like a mouthful, just slow it down. Self, well, that's, you know, this object. get my center point. Well, that's a point 3D object. Ask that point 3D object, what's my distance to other dot center point, which is another point 3D object. So if it looked like a lot to chew on at once, chew it slower. That's all. But that's all that's going on there, which is kind of neat. And then, I mean, really, the other two methods are the same as they were before. The only method that really needed a change, other than the constructor, was the distance between points. There we go. We've removed the x, y, z attributes from the sphere, put it into its own object, and look how easy it was to like repair the sphere class. And now the code's more general. It's kind of nice. Kind of like, I like how we've offloaded all the point-related work to a point class, because you know that makes sense. All the sphere-related stuff is in the sphere class, and if the sphere needs to do anything with the points, well, it goes and asks its points class to do the stuff it needs to do. It's just a different design of the same, ultimately the same functionality. Now, here's something interesting. Here is the updated equals method. I check if the radius values are the same, but then I don't need to check if the x, y, and z are the same. No, what I need to know is if the point 3D objects are the same. And the best part about all this is the sphere doesn't know what it means for 2 points to be the same, but the point 3D objects do. So on line 27, this right here, whatever, it's comparing two floats. But here, what am I comparing? What is the type of the things I'm comparing here? This isn't a trick question. Point 3D objects. And point 3D objects, they know what it means to be equal because we define the equality for them. So when I say self.centerPoint equals other.centerPoint, it actually goes and calls the equals for the point 3D class, which is really awesome. It'll be similar for the repr as well. If I go here now and I print out my sphere, look what we get. Well, first of all, look at what the sphere's repr does. Sphere, parentheses, center point equals, and then we say, yeah, just, give me the string of the center point, comma, radius equals, and then whatever my radius is. But when I call, give me the string of the center point, it goes and it calls the repr from the center point, or from the point 3D object, from the point 3D class. So it's delegating all this work. The sphere doesn't need to give a shit about how it prints out, how it represents a point 3D. It doesn't care. All it has to do is ask the point 3D what it is. And it tells the sphere, and the sphere goes, okay. Watch what happens if I do this. This is going to be a terrible one, but... Oh yeah, this test will fail now, yeah. Okay, and now when I run this, and that shouldn't actually have to change. When I run this, there. Now, when I get the string version of the point 3D, I get what the repr said, which is return that nonsense. But see, at no point did I directly call, give me the string version of a point 3D. The sphere class did that for me. I asked the sphere class to give me its string representation, and in order to do that, the sphere class needed to know what the point 3D's representation was. So it asked a point 3D object, hey, give me your representation. It did it. It gave it back, put it nicely in the string representation, and then gave it back to me. And then I could print it out. Now, we really are at a bit of a, we really have a bit of a problem now. It's starting to get, our assert tests are starting to become very, again, there's nothing wrong with them. They're doing the trick, but they are limited. They're becoming hard to keep track of. You've just got this giant wall of tests. It's hard to think if you're being thorough enough of all these things. All of these tests starting to have a bunch of like setup code required. Now there's going to be even more setup code. In order to test a sphere, I need to make point 3D objects that I have to give the sphere first. It's getting very difficult. Yeah, it's getting hard to tell them apart. They're getting all jumbled together. It's not easy to look at each line and know exactly what it's testing. Sure, you could look at a line. You could look at a line like, oh yeah, well this is clearly checking that the absolute difference between these 2 points is like that. But why? Why do I care? Why is that one important? Is that test checking an edge case? Is it just a general case? Why is that test important? These tests are starting to lose obvious meaning. When I had a nice simple function, and when I say simple, I don't mean like what we talked about like week 2 of the semester. I mean like any function you write now where it's just this nice, well-written, well-contained unit of functionality. It's a nice function. And you write a few assert tests below it. Check when the inputs are this, when the inputs are that. When the inputs are this. Did it all work? Good. Each test is easier to follow, but now we're testing classes. We're testing objects, and objects have multiple attributes and multiple methods associated with them. There's a lot of tests that need to be for each individual class you write. Where when you have a function, it's a little easier to look at and go like, yeah, I can see what they're testing about. Now, we've got these walls of tests. Am I even being thorough? I don't know. It's not easy to know what the test is looking at anymore. For example, assert that 0.01 is greater than the absolute difference between the distance of that. We can piece it together if we wanted to, but it's not immediately clear. And it's hard to get a sense, yeah, of how thorough our tests are. We're going to have to get there's going to be a lot of like duplication. If I start to want to test my like distance method, for a variety of different like points, what if point A is here and point B is here? What if point A is here and point B is here? What if point A is here and point B is here? What if point, all these different ones, suddenly there's going to be a lot of like duplicate tests with all slight variations and whatnot. Especially if each of them also needs setup code where we need to create the points and create the objects, and then we can test this one, create points, objects, then test it. This is getting difficult. But the good news is, there's a nice, way better way to do it. Python has a built-in testing framework called unit test. There's another really popular one. I don't think it's built into Python called PyTest, but we're not going to touch that one. We're going to use unit test. Unit test is given to us for free to use. We're not going to start this topic today. We don't really have enough time, but the next topic is going to be about transitioning to using unit test instead of using our assert tests. I will warn you, some of the stuff that we're going to need to see to use first of all, The reason we haven't been using unit tests from the very beginning was because there was a lot we needed to know before much of the stuff inside unit test would make sense to us, right? That said, not everything that we're going to see and use in unit tests is going to be immediately obvious to you or something that you're familiar with. It's just we had to get to a certain point where we could use it, and some of it might be some magic code that you kind of just have to go with. But we know enough now that you should be able to tackle this fine. And what's nice about unit tests is it really gives us a way to be clearer about what each test is doing. It slows us down, which I know sounds like, well, I know that sounds like, well, I don't want to be slowed down. But remember, writing code quick is the slowest way to get to a solution, right? You need to be taking your time and being deliberate and very thoughtful and have intention behind everything you're doing. And the way of doing unit tests is really good for that. It slows you down to make sure everything's working really well. It's really nice. So yeah, assert tests are becoming difficult to work. Consider circle, point 3D sphere class. Each one had some setup code. Assert tests get jumbled together. It's not easy to what the test is testing just by a quick look. And there's many similar tests with a lot of redundant code, but Python has unit tests built in, which has really great ways for checking that things are, it provides a way to automatically do the testing for us, which is really nice. It's got built-in special types of asserts. So when you do asserts, there's a little bit more like variety of the asserts you can make. You can have shared setup and shutdown methods so you don't have to repeat, be redundant. And at the end of it too, it gives you a much nicer like report of the results of your tests. All of your assignments have been run with unit test to actually do all the checking of all your code, which is really nice, by the way. But because there's really no sense in starting this topic right now with 6 minutes left, and I know there's the test tomorrow. Does anyone have any questions? First of all, does anyone have any questions about anything we talked about and or the test tomorrow? Yes, we do have a test tomorrow. Any questions about it? No, you're all good? You're all happy? You're all set? Yeah.
Is it covering the entire what we've covered so far, or
Yeah.
Okay, so
Or is it what?
Like, is it everything up to date, or is it anything past test 1?
It's everything up to date. It's not possible for me to make a test on classes if you don't know what an if is, right? So like it has to be a cumulative. It's not possible for it not to be. So yes, it is a cumulative. It could cover everything up to and including today. Technically it could. It's already written. I've made it. It's very similar format to the first test. The first test had 10 short answer questions. This one has 5 short answer questions. The last one had 1 short answer question. This one has 2 short answer questions. That's all. That's the biggest difference, I would say, in addition to the content, of course. But expect it to feel very similar to the first test, just different content. Any other questions? Going once, twice? All right, I'll see y'all tomorrow.